final types of variation we'll look at are called joint and combined. And this is essentially a way of combining the two types that we already have. For our first example, we're going to look at the volume of a can that varies jointly as the height of the can and the square of its radius. A can that has a height of 8 and a radius of 4 has a volume of 402.12. And we want to know what happens if we change the height to 10 and the radius to 2. This time we have this word varies jointly. And essentially all that means is a double direct variation. So we have volume is equal to our constant. Jointly tells me I have the height of the can and the square of the radius, and we will be multiplying those since they are both direct variation. If our volume is 402.12, we have a height of 8 and a radius of 4. We can solve this to get approximately 3.14 equal to K. So now I have a value for K for this problem. I now want to change to a height of 10 and a radius of 2. And when I do this, I get a volume of approximately 125.66. We'll now look at the time required to process a shipment of goods varies directly as the number of goods and inversely with the number of workers on the shipment. A shipment of 15,000 items with 8 workers takes about 10 hours. So we want to know how long it'll take 20,000 items and 12 workers. So this is an example of a combined variation problem. We know that the time required varies directly as the number of goods. We'll use T for time and G for goods. However, it also varies inversely with the number of workers. And I'll use W for workers. So we have this combination of direct and inverse variation. We know that it takes 10 hours when G is 15,000 and W is 8. And if we work on solving this, we get 0.0053 is equal to K. So now we have a set value of K that we can use from now on. I want to know what happens if I have 20,000 items and 12 workers. And if you work this out, you get that it should take approximately 8.9 hours. So just under 9 hours. For our last example, we're going to consider the load of a horizontal beam. This varies jointly as the width and the square of the height, and inversely as the length. So for this one, we are going to combine both joint and combined variation. Before we go on with the rest of the problem, we see that our load varies jointly as the width. So for load, I'm going to want to use L for something else, so we'll use H. Jointly means I'm going to multiply the width and the square of the height. Inversely means I'm going to divide by the length, which is what I want to use L for here. I know that this load is 360 kilograms when my width is 0.1, my height is 0.06, and my length is 6. If we solve for K here, we'll see that K is actually equal to 60,000. Or 600,000 rather. So now I have my set K and I can stick in my information. We're now considering a width of 0.2 and a height of 0.08, and then a length of 16. And if we work this out, we get that the maximum load it can carry is 48 kilograms.